Assalamualaikum and a very good evening to all of you. So now we will continue to the second part of our topic for construction noise. So for the second part, I will cover on construction noise propagation. Okay, as a continuation from the previous topic. Okay, this evening we have covered on part 1. So hopefully, as for now, we will continue the next part, right? Alright, so as usual, this is our quick check. Okay, ini just now keep on tracking our progress lah untuk this topic ataupun my parts. Okay, tadi kita dah cover on part 1, right? For construction noise issues and management. And as for now, we will continue to this one, part 2, construction noise propagation. And these two topics, the rest of the parts, we try to cover by tomorrow. So if possible, saya cuba habis awal, okay? Sebab saya dimaklumkan esok ada meeting kan dengan PM Azirudin. Jadi ke meeting tu?
Jadi doktor.
Jadi So pukul berapa tu esok?
Pukul 8 kot doktor.
Oh malam lah proceed malam.
Malam.
Alright.
Physical kan?
Okay, so yang meeting kat KL lah kan? Bangi, alright.
Doktor Azrudin yang tidur kat KL.
Oh, okay. So maksudnya semua boleh attend ke esok? Boleh join meeting?
So far discussion kita macam semua akan datang. Sebab memang dia minta untuk buat physical.
Right.
So sebab cuma dalam 6 orang je.
Okay. So last week memang dah ada kelas dengan Dr. Azrudin?
Last week kita orang postpone pergi ke esok.
So
dia combinekan, dia squeezekan semua untuk kita discuss esok.
Alright, so maksudnya esok adalah first meeting lah?
No, second.
Oh, second. Okay. So hopefully the rest of topics ni yang saya punya part, saya cuba cover esok and cuba habis awal sikit so that all of you sempat lah to prepare for the next meeting. Okay?
Doktor, sorry nak tanya. Kita punya lecture note semua doktor tak upload lagi kan?
Belum.
Okay.
Okay, nanti saya akan
tersilap.
Boleh. So selepas kelas semua ni saya akan upload lecture notes, video recording and any additional ni lah guidelines atau reference macam yang first part tadi Once dah orang kata dah available, dah ready, nanti saya inform through WhatsApp group, okay, so that all of you can refer to e-learning. Okay, so saya tak ada dah untuk quick check, assessment pun saya dah mention petang tadi. Okay, so let's proceed to our second part of this topic. Alright, basically this is several subtopics that we are going to cover for the second part, construction noise propagation. So ni adalah dia punya pecahan tajuk untuk construction noise propagation. Kalau kita recall balik, for the first part, kita dah tengok issues and construction noise issues and also management in terms of dia punya overview, in terms of the how we want to manage the noise. So for the second part, we are going to focus more on description of sound itself and also the noise. Okay, so we are going to cover on these characteristic types. Sebab yang ni it's quite important because kita kena differentiate lah jenis-jenis characteristic of noise sebab different kind of noise will give different dia punya noise generation dan juga in terms of types of noise. Okay? As I mentioned for the part 1, nanti saya akan share juga berkenaan jenis-jenis noise kat sini. And then Another part, we are going to cover on the noise intensity, and then what are the main components ataupun noise indices related to lah, maksudnya main item for construction noise. Okay, cuba cover on this part. And at the end, kita tengok juga factors inclusive propagation and sound indices. Okay, so let's proceed to the first sub topic for part 2, sorry. Okay, so basically this is just a general overview for sound. Okay, what actually sound is in terms of its description and also definition. So I'm sure that this one, if we refer back, if we try to recall, it's actually relates to the physical science lah, ini lebih kepada physics punya ni, just a recall lah, quick recall, so that kita boleh relate, and yang paling penting kita cuba differentiate these two terms, sound and also noise. Okay, because kalau kita tengok sound and noise ni dia quite the same, but it has its own definition. Okay, so we need to use the correct term for each situation, right? So what is actually sound refers to? So sound will produce when air is disturbed. Ini saya rasa semua dah tahu lah kan, sebab itu relates dengan physical science. Okay, so it refers to anything that vibrates in the air and create a sound or pressure wave. So kalau kita tengok kat sini, tuning fork ni, so dia dah, once ada vibration, kita dapat tengok sini ada sound or pressure wave, which is condense and also reflection. So condensation and reflection kat sini represent different situation lah. So kalau condensation, kita ada high pressure, so tekanan kat sekali sebab dia dah condense, and then kita ada reflection, which is represent the low pressure. Okay, so ni pun memang sangat basic lah kan. And then untuk kita punya topik, nanti kita akan tengok banyak lagi apa dia punya terms ataupun terminology. So kalau kita sebut sound ni, the main terminology that we are going to use is sound pressure level, or sometimes we call it as SPL, and the unit, the short form will be LP, dia punya LP. And then measurement unit of sound, we need to remember that in decibel or dB. Okay, and the most important thing is that dB scale is logarithmic scale. Okay? So nanti saya akan share juga in terms of the overview for the calculation. Kita kena tahu bahawa calculation of sound ni dia bukan arithmetic, maksudnya dia bukan tambah macam biasa. We need to apply the log function. Okay, because kalau ikut dia punya tu, it's quite complex as compared to the common value, right? Okay, that's the overview or introduction for what's actually sound refers to. And then tadi kita dah tengok sound, so kita cuba differentiate in terms of the description of noise, so that kita tahu sound proper, and then noise ni apakan dia refer to different situation lah. So in short, noise is refer to any unwanted sound. So ni dia punya relation that irritates human ear and may cause annoyance. So maksudnya any sound, maksudnya yang sound yang kita interpret that one will be irritates, that will annoy us, so we will categorize it as noise. So maksudnya kat sini bukan semua bunyi itu adalah noise. So kita kena differentiate lah. Kadang-kadang dia punya interpretation ni based on individual perception. Okay, maybe some of us fikir sesuatu bunyi tu tak consider as noise. Okay, maybe untuk orang yang sensitif, dia boleh categorize the loud noise will be a loud sound will be a noise. Okay, for example lah, contohnya Kalau individu seseorang tu suka dengan music, for example, lagi-lagi music yang memang quite hardcore, so bagi dia sebab dia dah terbiasa, so that one will not become an issue lah, maksudnya bukan satu problem ataupun bukan satu noise bagi dia, tapi that situation, the situation will give ataupun will affect in terms of noise annoyance. Maksudnya orang lain maybe interpret that loud music as a noise. Okay, so that's why dia punya perception varies from one to another, right? Okay, so another thing related to noise is that it can be seen, smell or taste, but it's everywhere. So benda yang kita tak nampak, kita tak dapat rasa atau bau, but noise is around us, okay, in our daily life, either indoor or outdoor. So, sama juga based on our perception lah. Kalau kita dah categorize it as noise and it is a loud sound which affect our daily life, so that one will be categorized as noise. Okay, and it's quite difficult to be managed and regulated. However, with a good guidelines, with a proper guidelines, we try to manage to an extent that is manageable and also appropriate lah for us to have a proper noise management. Okay, and in terms of the challenge, sebenarnya dia become a greater challenge as cities grow. Sebabnya lagi tinggi population, lagi develop an area, so of course there is increase of noise sources, so that one will be a challenge for us to manage noise. Okay, and we need to categorize, or we need to recognize noise as a major threat to human well-being. So that's why we are focusing on noise management as part of our sustainability or sustainable living, sustainable development, right? Okay. And the other thing, just a brief overview for construction noise. So, just now kita dah tengok interpretation of noise itself, and then construction noise, for sure it is unwanted noise by the construction activities. So yang ni pun memang kita dah cover tadi untuk previous part, right? So basically it has the same physical theory as the sound, which is caused by the collision of molecules. Ini lebih pada dia punya definition jugalah. That refract and compress with changes in aperture and reflect sound wave. Just another definition ataupun description of construction noise, right? Okay, so okay. Yang ni yang saya cakap we need to differentiate lah sound and noise. So these figures or this visual shows the difference between sound and noise. So kalau kita tengok kat sini, on the upper part we have illustration for the pure sound, which is for example musical note. Okay, so this can be considered as just a sound, just a pure sound, instead of kalau kita tengok comparison with the bottom figure, due to hammering, memang yang seperti mana kita tahu lah kan, hammering ataupun apa-apa lagi activities yang require ataupun generates excessive noise, excessive sound will be considered as noise. Kalau kita tengok pattern dekat sini pun memang dia tak stable macam pure sound punya ni wave. Okay, so kat sini dia dah bercampur, so that's why dia create noise ataupun generate the noise. Okay, this is just a simple illustration to differentiate pure sound and also noise. Okay, so the next one we are going to cover on the characteristic of noise. Okay, so we need to remember that once we mention about noise, we need to know its characteristic. So in overall, there are three main characteristics of noise. Or the first one, wavelength, which is with the symbol of lambda. And then we have frequency with F. Then we have amplitude P. So later on, I will share the figure to make it easier so that we can understand it better, right? So for the first characteristic of wavelength, we have lambda here, which represent physical distance between two amplitude peaks. Okay, sorry. So kalau kita tengok kat sini, this is wavelength. Okay, so this is the amplitude. Okay, that represent the wavelength. And then this one full cycle. Okay, this wave, sound wave represent the wavelength. Okay, so it can be minimal or maximum, maksudnya upper level or lower level, and then measured in meters. Wavelength, sebab dia punya panjang wave tu sendiri, so it will be measured in meter, which shows a tone of sound, tone sound. Okay, so kita kena relate lah dengan this figure. Alright, so next we have frequency. Frequency refers to number of wave per second, and dia punya unit adalah hertz, Hz. Ni pun saya rasa most of us dah quite aware with this. And then related to frequency, construction noise itu sendiri a complex mixture of noise level, okay, noise level variation, amplitude from each frequency. Maksudnya condition of construction noise tu very complex, which consists of a variation of noise level for each frequency region. Okay. New to that, we have the third characteristic of noise. We have amplitude, which represented by P. Okay, so amplitude, if we refer to this figure, this is showing the amplitude, which is this one for the upper part, and this one for the lower part of the sound wave, okay, variation in air pressure. So, amplitude basically associated with the noise level received by the human ear. So, the higher the amplitude, maksudnya lagi tinggi amplitude, the higher the sound pressure level. So it is directly proportional. The higher the amplitude, P, is the P, so the higher the SPL or the LP decimal. Okay, so these are the basic characteristic of noise. Alright, and then just a visual figure represent what we have just now, the characteristic of noise. This figure shows or presents the sound wave generation. Okay, on our left side, we have example of construction noise activities, which is for pilot activities. So the sound wave, ataupun dia punya sound travel to the nearby receiver. It can be the nearest residential area. So that's how this what we call, that's now the illustration of characteristic of noise itu sendiri. Okay, so kita kena faham lah dia punya basic ni, dia punya wavelength, dia punya amplitude, dan juga satu lagi frequency, because all of the characteristic are interrelated. Saya akan tunjuk simple formula which relates all these three characteristics. Okay, so another characteristic of noise kita boleh juga tengok in terms of the types of frequency, right? So for your information, there are three main types of frequency. We have low frequency, medium, and also high frequency. So kalau kita tengok kat sini, low frequency dia punya wavelength quite panggil jarak, kan? Okay, then medium is become more rapat lah. And then this one kita tengok lagi condensed. Dia ada condensation kat sini, so that one represent high frequency. Okay, so in overall we have three category of frequency types: low, medium, and high. According to each of these frequency range. For example, 10 Hz to 1000 Hz represent the low frequency, and similar for the rest. Okay? 10 kHz to 4K for medium region, and the rest will contribute for high frequency. Okay. So here we have the figure lah. This figure, we have this one. Okay, and then for this one, dia nak represent what's actually each frequency region refers to. Okay, so kalau region 20 Hz ke bawah, less than 20 Hz or less or equal to 20 Hz, it will be categorized as infrasound. Okay, so maksudnya kalau kita tengok kat sini untuk acoustic punya purpose, we only consider this one 20 Hz up until 20K, 1000. Okay, so ni pun kita punya range of hearing threshold, human hearing threshold. So nanti saya akan tunjuk juga. And for the upper region, we have 20K to 2 million Hz. Okay, kat sini dia categorized as ultrasound. Okay. So ni adalah dia punya visual ataupun illustration to differentiate different types of frequency region. Okay. Okay ke semua? Boleh faham
Okay, doktor.
Yeah, so kalau ada anything to ask macam biasalah, kita sama-sama discuss, right? Okay, so this is the formula that I mentioned just now. Maksudnya dia punya relationship between this one, wavelength dan juga frequency, right? Kat sini kita ada juga speed of sound. Okay, so kalau kita tengok kat sini, dia punya formula, wavelength lambda is equal to speed of sound C. Dia punya simbol C divided by frequency. Okay. So kalau kita tengok betul. Kalau dia punya wavelength decrease, so that meaning that frequency akan decrease. Kita relate balik dekat sini lah. Wavelength ni besar, dia low frequency. Okay. Kalau wavelength ni rapat-rapat, okay, condensation, so dia punya high frequency. So dia indirectly proportional lah to these two parameters. So again, lambda ataupun wavelength refers to the distance between two consecutive points. So saya dah tunjuk dekat previous figure, which are vibrating in phase. And then C here, speed of sound depends only on the medium the wave are traveling through, speed of sound. And then we have frequency. So this is the basic formula for relationship between wavelength and frequency. All right. So continue to that, this is the interpretation for the previous formula ataupun previous relationship. Okay. So it is mentioned that wavelength is an important characteristic for acoustician. So maksudnya wavelength ataupun lambda tu dia sangat penting for the acoustician ataupun anyone like to manage the sound in treating the room environment and also to design the noise barrier. So wavelength ni adalah main component lah. They need to consider bila dia nak treat the acoustical condition in room and also to design the noise barrier. Okay. So we need to know that sound propagates at the speed of approximately 1.34 meter per second in air. Ini yang macam saya dah mention tadi, the higher the frequency, the shorter the wavelength, right? So kalau kita tengok kat sini, dekat frekuensi 20 Hz, with the wavelength 70 meter, so dia punya objek kena besar daripada this size in order to block the sound wave. Ini lebih kepada ni lah, design the noise barrier. Okay. So that's why wavelength is very important. Maksudnya any related person dia kena tahu the actual wavelength of the sound so that dia boleh come out with a proper control method lah. Kalau tak, dia punya design tak unable to cater the problem, right? And the other thing is that low frequency will produce low tone sound. For example, yang ni selalunya relates dengan heavy equipments, construction equipments of plant and machineries such as lorry and excavator. Okay. So this situation relate to this kind of construction machineries due to its longer wavelength. Selalunya sebab kalau kita dah tengok tadi, low frequency yang rendah, dia ada longer wavelength. Dia punya wavelength jarak-jarak. So in actual practice, it's actually quite hard to provide sufficient mitigation because of this low frequency punya situation. Sebab low frequency is quite complex in terms of treatment. So that's why we need to come out with a proper mitigation. They can come out with the proper mitigation method so that we are able to cater this problem. Okay, so this is the example just now, lorry and also excavator for the low frequency category, right? In terms of construction plant and machineries. Okay, so I think that's all for the characteristic of noise. Okay, sorry, that one, the relationship of wavelength and frequency. The next one still on characteristic of noise, but we are going to focus on this one, for frequency analysis. Okay, so tadi kita dah tengok dia punya wavelength, kita dah tengok dia punya satu lagi frequency. So now we are going to focus on frequency analysis. Okay. As I mentioned, kita kena tahu dia punya region of the frequency so that method yang kita guna tu sesuai lah sama ada untuk low ataupun high frequency punya region. So analysis of frequency spectrum is very vital or important for evaluation or determination of noise mitigation, right? In terms of the frequency range or region, as I mentioned previously, 20 Hz to 20,000 Hz adalah range of frequency that human ears can detect. So maksudnya kita punya telinga, human ears can detect this range of frequency. Okay, most sensitive adalah dekat kalau ikutkan dekat range 3 to 4 kHz, okay, yang paling sensitif lah. Okay. And then for measurement purpose, okay, ni kalau buat kita punya on-site measurement. Untuk measurement nanti saya akan share juga, I think that one for the next part 3, kita akan cover on the noise measurement. So just a brief information. Untuk measurement kita akan cover on sound pressure level and at the same time there are capability of the device ataupun equipment to measure the frequency. Okay, so for the measurement purpose, frequency of sound are divided into two type lah, sama ada one octave. Octave ni dia macam class ataupun dia punya group of the frequency. Okay, octave, and then we have 1/3 octave band. So nanti saya tunjuk dia punya illustration lah untuk this octave band. Maksudnya dia punya band frequency tu. Okay. Alright, this one yang saya cakap tadi. So basically untuk measurement purpose, untuk noise monitoring semua tu, mostly kita akan refer to this one lah. Kita akan guna 1 octave ataupun 1/1D, dia refer kepada 1 octave ataupun this one, we call it as 1/3. Okay, so the other one we have narrow. Actually this third category refers to narrow band, maksudnya dia punya band tu lagi kecil. Kalau kat sini 1/3 sebab kalau kita tengok setiap group ni dia ada sub frequency, dia ada 3 ni lah, 3 bands. That's why kita panggil dia 1/3. Macam ni kat 100 dia dah memang ada 1 band je. Kalau kat sini dia lagi narrow, dia lagi kecil-kecil. So sometimes ada juga orang guna 1/10, okay? Ada juga 1/12, depending on the purpose lah. Tapi most of the time, previously saya sendiri pun kalau buat noise measurement, saya guna 1/3 lah for the purpose of the noise monitoring. So this one is the common band, okay, frequency band. Okay, difaham yang ni? Okay. So next one, kita akan tengok juga. Ini saya dah mention juga on our first part, okay, previous session. In terms of types of noise, okay, maksudnya dia punya types of noise in terms of the classification. How we classify the noise actually. Okay. So kalau kita tengok sini, main classification we have satu outdoor, which is environmental, and then the other one we have indoor. Okay. So for our purpose for this class, we are basically refer to this one lah, environmental, sebab under this category kita ada construction here. Okay. So sebenarnya types of noise tu sendiri sangat meluas. Okay. Dia ada dia punya own situation or condition which differentiate each of these noise. Okay. So the reason why we need to differentiate this kind of noise, because later on each of these category, okay, for example traffic noise, we have construction or neighborhood noise, they have its own regulation ataupun methods on how we assess, how we evaluate the noise. Okay, that's why kita kena detect ataupun identify the right type of noise so that betul lah dengan so that it match, okay, it match the assessment or evaluation, right? Okay, so for indoor noise, just inilah additional information. Indoor building noise, indoor noise ataupun building noise, meaning that within the room ataupun the space, juga merupakan satu cabang ataupun types of noise. Okay, for example kita ada classroom, noise condition, office or hall, and then dekat kilang tu sendiri manufacturing. Okay, kita ada ni lah several other types of noise. Okay, each of these ones again dia punya own guidelines that we need to refer to. And yang paling penting, guidelines tu lah yang akan outline all the permissible limit. Okay, sebab previously banyak juga case, okay, yang mana yang not quite aware lagi, dia tak berapa tak well lagi berkenaan, well exposed with the different kind of noise, dia tersalah refer permissible limit. Okay, so that's why we need to differentiate different types of noise. Okay. So far harapnya kita semua ni lah dah faham yang kita fokus on the environmental noise which is outdoor, and our main focus is construction noise. So kat sini adalah dia punya related regulation, related guidelines. Okay, yang ni dah cover dekat part 1 tadi. Ada juga lagi saya akan cover for the next part. Alright. So So continue still on different types of noise, tapi yang ni kita fokus kepada karakteristik dia sebab we need to know that different types of noise consist of different karakteristik. Okay? Yang paling common ataupun yang paling basic adalah we have these three type of characteristic. Steady, maksudnya in terms of nature of noise itself, we have steady noise, non-steady and also impulse. Okay, so each of these types ada dia punya own condition. Okay, for example, untuk steady kita ada two categories, constant and also intermittent. So each of these type atau characteristic has its own example lah, relates to, for example, constant steady noise. Kita boleh ambil sebagai contoh generator, pump, ataupun electric motor ni kan. Kalau intermittent selalunya represent by the air compressor. So nanti saya akan tunjuk dia punya figure juga to differentiate all this kind of noise characteristic as part of the jenis noise. Sama juga non-steady and impulse, dia ada subcategories. For non-steady, we have predictably fluctuate, maksudnya dia kategori non-steady, tapi in terms of fluctuation, dia ada satu predictably punya fluctuation as compared to the other one, we have irregular fluctuating. So nanti saya akan tunjuk And then for the impulse, dia boleh jadi dua condition juga, similar impulses and also isolated. Each of this one again ada dia punya jenis lah, macam isolated impulse mostly relates to the thermal flow. Okay, so that's why as I mentioned, noise sendiri sebenarnya dia banyak karakteristik dan juga jenis. Okay, this is dia punya figure ataupun visual lah berkenaan each of the characteristic. Just now kita ada steady noise characteristic, tapi dia ada dua jenis di sini. First and second type, constant and intermittent. So untuk constant, kalau kita tengok dia steady tapi dia dikira sebagai steady sebabnya dia punya up and down sini, dia punya recording just a small variation. So that one will be considered as steady. And the intermittent noise, dia ada dia punya naik turun kat sini. Okay, tapi kita tengok dia still lagi steady sebab dia punya penurunan, increase and decrease of the pattern in a uniform pattern and in a steady pattern. But kalau kat sini dia ada perbezaan lah dari segi wavelength sendiri kan. Okay, so itu ada dua jenis, tak ada pembahagian kat sini. So non-steady ada dua jenis, large fluctuation, maksudnya dia fluctuate tapi within a larger wavelength, and then this one non-periodic sebabnya dia tak ada uniform pattern. Okay, irregular fluctuation here. So both of these are considered as non-steady, but dia ada fluctuation here as compared to previous one. And similar impulse. Impulse pula yang membezakan dengan yang previous one in terms of the dia punya in terms of the kenaikan dan penurunan tu within kalau ini selalunya less than 1 second. So tiba-tiba dia ada just a peak level, so that one will be considered as impulse. Jadi ada sudden change of the sound level. Okay, jadi macam repeated lah. So that's why dia ada similar impulses, and then this one isolated. Maksudnya sudden isolated impulse. Right? That's the untuk kita punya lah as for our additional information and for our knowledge regarding the characteristic of noise. Okay. And then So up until now we have covered types of noise. So far okay Boleh ke semua? It's already 9. Semua masih okay Right? So boleh faham saya berkenaan subtopik yang kita dah cover so far. Okay, then the next one. Okay. We are going to cover on construction noise intensity. Okay. So basically noise intensity ni memang part of the main component of noise itself. So intensity is refers to sound energy transmitted through a unit area perpendicular to specific direction. Okay, so nanti saya akan tunjuk juga dia punya contoh. Inilah sebenarnya intensity ni refers kepada apa. Okay, so in terms of the unit, dia watt per meter square sebab dia relates dengan unit area. Okay, and for the construction equipment, it can have intensity of more than 1 watt per meter square. And on the other hand, maximum intensity that our ear can hear or our hearing capability is around 1 watt per meter square maximum, and the lowest will be 1 multiplied by the 10 to the power of negative 12. So this is the lowest intensity for human capability, human hearing capability. Okay, and kalau relate to this noise intensity, we have two main situation ataupun two main types of listening. We are going to cover this one: spherical radiation and hemispherical radiation. Okay, this one will be related to the construction plant and machineries itself. Okay. Okay, for the first category of noise intensity in terms of spherical radiation, yang ni common ni lah, yang paling common kita akan relate dengan piling activities. Okay, sebab piling activities ni dia originate from drop hammer. Okay, kalau kita guna apa tu? Drop hammer untuk piling works may be generated above the ground. Okay, sebab dia punya hentakan kan, dia punya drop tu, tapi dia punya impact adalah dekat bahagian atas. So it will be considered as above the ground. Maksudnya hanging lah benda tu. In this situation, the height keep moving and the sources, maksudnya bunyi tu sendiri can be treated as a point source. Okay, so bila the point source, dia akan emanating in spherical direction. So nanti saya akan tunjuk dia punya beza spherical dan hemispherical. So kalau on the other hand we have hemispherical, yang ni most of the construction machineries lah represent by this one. For example, we have compactor, excavator, lorry and so on. Most of them memang noise generated on ground. Okay, so that's why it will be hemispherical, because the sound will be reflected because the plant and machineries located on the ground. So this is the related formula for both calculation of noise intensity in terms of spherical and hemispherical radiation or condition. Yang membezakan adalah, kalau kita tengok sini, adalah surface area. Ini untuk surface area circle, this one for hemispherical lah, 2 pi r square. Okay. This is the only difference between these two condition or radiation. It's just a straightforward formula. Next, saya nak tunjuk dia punya ni lah, visualization ataupun illustration. Okay. So kalau kita tengok sini, piling machine ataupun piling activities represented by spherical radiation. sebab dia punya noise generated on the upper part. Maksudnya dia tak betul-betul on the ground. So that's why dia punya noise emission in spherical radiation. Okay. So harap semua boleh ingat, boleh differentiate. Itu maksudnya spherical radiation refers to. And kalau kita compare yang kat sini, memang dia punya noise touch ataupun sound tu boleh reflect on the ground surface. So it form spherical radiation. Spherical radiation. So most of the conceptual machineries lah memang categorized under this condition or radiation. Okay. So yang membezakan tadi adalah dia punya formula lah. Kalau yang ni surface area 4 pi r square. So 2 pi r square. Okay. That's just quite straightforward for the intensity calculation for both condition. Right. Boleh semua? Okay. Faham ke? Okay. So semua senyap ni hopefully okay lah Okay, so if you have anything to ask, you may do so. Okay. Saya risau juga untuk saya explain nanti banyak yang tak faham ke apa. Just tanya je lah mana-mana part yang tak clear. Okay. Next, up to this one, kita dah cover on construction noise intensity. Then we will proceed on this one, some pressure level. So tadi on our part we have mentioned this one. I have mentioned this one as PL, some pressure level, or we can call it as LP. Right. So some pressure level itself, macam mana dia punya relates dengan intensity. Sebenarnya some pressure level ni adalah intensity of noise at receiver. Maksudnya dekat at receiver point lah, tak kisah workers ataupun resident. And the difference is that the unit is in Pascal. Because this is the original unit for sound actually, and then this unit need to be converted to decibel because in overcoming the problem of handling huge range of numbers, 1 trillion numbers. Sebab kalau kita proceed dengan Pascal, dia punya number sangat besar. That's why at the end kita come out with this decibel unit. So to make it to shorten the values, right? In terms of the Pascal, 2 times 10 to the power -5 is the lowest pressure that our hearing can perceive, and 20 Pascal will be the highest pressure that human hearing can perceive, right? That's regarding the sound pressure level. Alright, juga in detail kita akan tengok juga berkenaan loudness. Okay, sebab as I mentioned previously, all these components, all these terminology interrelated because they are generated. Maksudnya macam tadi intensity, lepas tu dia generate pula sampai pressure level. So all of these are interrelated. So that's why kita kena differentiate lah, kita kena faham. Right. So sound pressure level in terms of loudness adalah evaluation of sound intensity or noise level by human ears, which we can categorize it as subjective. It's subjective evaluation. And then evaluation using loudness ni, dia menggunakan both sound level and also frequency. Both sound level and frequency are evaluated. Sorry. So kalau kita tengok kat sini, sound pressure level here versus with frequency. So for the evaluation, we use both data or both value for the purpose of loudness evaluation. Okay. Relationship between unweighted noise level in dB and frequency is called loudness curve of whole. Okay. So, ni kita panggil loudness curve. Okay. Yang ni kita kena ingat dia punya sound pressure level still in dB. So, later on nanti saya akan share berkenaan SPL in dB. But because there is conversion daripada dB kepada dB. And what is the reason that we need to convert this unit? Okay. Related to this one, okay, this is the loudness punya description. Okay, kalau kita tengok lowest curve yang paling bawah ni, adalah this one. We have 0, 20, 40, 60, 80, and the rest and so on. Okay, yang paling bawah ni adalah lowest point, which represent the lowest threshold. Okay, so maksudnya represent the lowest intensity that can be heard by human ear, with 10 to the power of negative 12 watt per meter square. So in general kita tak adalah nak kena tahu, jadi kita tak perlulah nak ingat ni, as long as kita boleh interpret this secara general, secara brief, kita boleh interpret this kind of graph. Okay. Next, continue to that, highest curve is the threshold of pain in ears with the 1 watt per meter square. Tadi yang paling bottom part kita ada 0 volt here. Okay, this one, the bottom line, and the upper line, top one, we have 100 volts with represent the threshold of pain. Maksudnya kalau kat sini memang dah severe damage lah to our hearing capability. Okay. And the other thing regarding this curve ataupun loudness curve ni, in between highest and lowest, the first one 0 to 120, dia ada lagi sub point ataupun sub curve. Maksudnya di sini ada je lagi banyak lagi lines supposed to be, tapi for the simplicity kita refer to this several curve je, 20, 40, 60 and 80, including 120. Okay. And the other description for this loudness curve adalah lowest point between 3 and 4 kHz is the most sensitive. Tengok kenapa dia most sensitive daripada sini. Ini 1K, 2K, and 3K. So 3 to 4. Okay, 3 to 4 here. Tengok dekat region ni, dekat this range, dia punya 4 ni memang rendah. Maksudnya paling rendah lah dia punya curve, which represent the most sensitive millimeters. Okay, so that's the description for this curve lah, right? Okay, so I think that's all for the description. Boleh kan semua? Saya harap semua bolehlah grab the main overview ataupun dia punya brief description lah. Okay. The next one, we are going to look at still on sound pressure level. Yang ni focusing on sound weighting. Okay. Ni yang saya cakap tadi berkenaan DBA sebenarnya this A refers to the weighting. Sebab we need to know that sound itself has a different weighting. Maksudnya dia punya pemberat lah, dia punya weightage. Actually there are 5 here, supposed to be 5, A, B, C, D, and Z. So we should have another one. A, B, C, D, and Z. Tapi kalau kita refer various type of the other reference, sometimes they just mention A, B, C, D, except for Z. So altogether we have 5 different weighting or weightage. So each of these weightage of sound represent different situation or different purpose. Okay, the first one we have A. That's why we just now I mentioned about DBA. So A weighting represent human ear sensitivity. So it will represent human ear threshold or capability. That's why we are focusing on DBA instead of the rest of these weighting. Okay, we cover all range of frequency. Okay, if we look at B basically most of the sound for musical purposes with intermediate level. Okay, so kalau untuk musical purpose, most of the time kita akan guna DBA lah kat sini. So DBA with the weighting. Similarly for the C, D and Z, okay, C most of the time represent low frequency noise such as machineries. For the low frequency, it can be heard but can be felt by human ear. Maksudnya kita tak dengar pun loud noise tu sebab dia at very low frequency, tapi for the long term dia might affect our hearing. Okay, and D is for high noise frequency, for example aeronautic noise. Okay, D, and last one we have baseline. Actually Z ni baseline, 0 or no weighting. Okay. Right, so that's all for the sound weighting or weightage. So up until now, hopefully all of us can remember lah this one, especially this DBA. Why we use DBA, right? Okay, so the next one we are going to focus on sound pressure level in DBA. So this one represent human ears capability or human ears threshold. Okay. Sound pressure level or SPL in DBA is very important unit to represent ear sensitivity. Okay, and kalau kita tengok yang tadi saya dah mention berkenaan DB to DBA. So how actually the method that we need to know to convert these values. Okay. Right. Apa saya habiskan sampai sini dulu. Maybe we need a short break. Okay. Okay, how we want to convert? We need to use correction factors. This one memang dah available punya correction factors. Kita akan tengok dekat correction table ni. So you need to take note lah sebab this will be part of the item that will in the calculation, right? Okay. The next one, kita ada juga SPL from the multiple sources. Okay. Kita boleh kira dia punya total sound pressure level. For example, multiple sources ni dekat side lah for the actual situation. We have noise generated from lorry, for example, and then we have excavator and also compactor, for example. So each of these contribute to different noise level. For example, this one 83, and this one 86, and this one 90. Just for the purpose example. So we can use this formula to come out with the total pressure level. Okay. As long as we apply this log function. So that's why during the earlier part, I have already mentioned that sound calculation will involve logarithmic function instead of basic arithmetical. So maksudnya kalau kita ada tiga sources of sound, okay, contohnya tadi we have daripada lorry tambah dengan excavator, and then tambah juga dengan compactor. So kita tak boleh simply plus all of these and divide by 3 for the average or the total sources, because sound is not an using arithmetical function. Kena guna logarithmic. Okay. So kita kena ingatlah dia punya ni apa dia panggil correct function for calculating the noise, the sound itself. Okay, this is the correction table that I have mentioned just now. How we want to convert dB to dBA. So if we have the value in dB, so use this table to have values in dBA. So this one dia relates dengan frequency. So each of the frequency ada dia punya ni lah vector ataupun dia punya correction vector. So just apply all of this sebab yang ni dah memang established macam ni. So we just need to apply. Okay, starting from 20 Hz frequency up until 20 K. Okay, 20 Hz. Right? So this is the main subtopic relates to the second part, which is on construction noise propagation. Right. So in relation to the noise propagation, most sound sources from construction equipment can be considered as point source. Right. Each sound source has its own power acoustic energy per second or watts. Okay. And then power, the percent power of each of the machinery measured at 1 meter distance from the source is known as sound power level. So kalau kita notice kat sini this one LW, previously we have LP. So yang ni pun kita kena differentiate sebab LP represent for sound pressure level, and then this one SPL have LW for sound power level. Okay. Both of these kita relate in this equation. This one sound power lah, sound power level, SPL dan juga LP dan juga LW. Right. So again untuk different radiation ataupun different situation of spherical and hemispherical radiation yang macam saya dah tunjuk tadi, dia ada dia punya own formula. Okay. For the first formula, we have LP, sound pressure level, equal to sound power level minus with this log function again, 20 log R actually the distance, related distance, minus with the constant. For the first case, kita kena minus dengan minus with 11 for the spherical radiation. And the main difference for the hemispherical, we only minus with 8. Both of these are constant lah, dia punya formula dah memang macam ni. Okay, untuk calculation, so far we will cover on next part lah, hopefully by tomorrow. Right, so these two are the main formula for on how we want to calculate the sound power level based on sound pressure level. Okay, tapi ada certain situation the what we call sound power level is still unknown. Maksudnya kita tak ada available data on the sound power level, so kita tak boleh nak dapatkan any values lah regarding the sound power level, and we can use this alternative formula, right, based on the first group. Okay, we need selalunya kalau case yang macam ni kita ada two values for sound pressure level, and then we have to distance. Here we have two different construction equipment. Okay. Alright, so still on construction noise propagation, but we are going to look at on factors influencing propagation. Okay, so kalau kita tengok kat sini, for based on this visual, based on this illustration, we have sources of construction noise here. Sources refers to the site preparation of construction project, and ini lebih kepada inilah early stage of the construction, site clearance and earthwork and so on. Okay, on the left side we have receiver. Similarly here on the right side we have also receiver. So dia punya transmission of noise being influenced by these several factors. Okay, for example, kita cuba cover in brief each of these factors. Kita ada atmospheric factors and then temperature effect, vegetation, ground attenuation, and also mode of operation of these construction plant and machineries. Okay, we are going to cover in brief each of these factors. Okay, for the first factor, we have atmospheric absorption. So this we call this factor very strongly with the frequency of sound wave and temperature. The other sub-factors related to the humidity and to a minor extent atmospheric pressure in the air. So ni dia punya sub-influence factor lah kepada atmospheric absorption. And it will be at the greatest high frequency in hot and dry air. So kalau memang waktu ataupun cuaca panas dan juga condition kering dan panas, so that one will leads to greatest absorption at high frequency, right? And related to this one also, atmospheric pressure increase linearly with the distance. Okay, maksudnya the greater the distance, dia punya atmospheric pressure also will increase. And dia akan jadi important as propagation path length increases. So they are interrelated in terms of the path length, in terms of the distance, right? Another thing is that some propagation for any nerve sources which is close to the ground for distance between source and receiver of less than 100 meter. So dia punya these factors influencing is independent ataupun not really significant. Okay, kalau in this kind of situation lah, in this kind of condition. Right, so that's regarding the atmospheric absorption. The next one, this is the first one, first factor. And then we have ground attenuation. Okay, this is the second factor, another factor which may affect the noise propagation from the noise sources to the receiver. Okay, so basically attenuation due to ground surface is caused by acoustic energy losses by reflection. Maksudnya from one point sources to what we call receiver. Here we have receiver and here we have the source of noise. Okay, obstruction. So attenuation ni mostly affected by the reflection. Maksudnya kalau kita punya transmission path dia reach the any ground surface, so that one will reflect. And depending on the type of ground juga, either dia hard surface or ada yang smooth surface, right? And when the source and receiver are both close to the ground, wave reflected from the ground may interfere with direct wave. Okay, so depending on the condition. Report again, reflection from the ground may result in attenuation. Sebab for sure kalau dah ada reflection of sound, dia akan influence the propagation. And again, strongly depends on the type of ground surface. Smooth and hard surface will give less absorption. Tapi kalau thick grass, yang mana surface yang bukan hard surface, dia akan absorb the sound. Okay? Instead of reflect, dia akan absorb up to 10 decibel per 100 meter. at specific range of frequency region 2000 Hz. Okay, so kita cuba tengok ni illustration, some example from the previous study. Okay, kalau kita tengok this three line represent hard ground, hard surface, mixed surface, maksudnya dia ada mix of hard and smooth, and this one is porous or smooth ground. So kita tengok the ground attenuation punya values. Okay, kalau dekat hard ground memang dia flat je lah dia punya reading. Okay. Porous ni yang ada ground attenuation. Okay, sebab different types of the surface. Okay. Masih okay sikit lagi. Sambung. Alright. So the next factor is obstruction attenuation. So the next factor yang influence the noise propagation mostly due to obstacle. Any obstruction atau obstacle. Sebagai contoh adalah barrier lah, tak kisah building, concrete wall or tree or any structures which intercept the line of sight between source and receiver. So ni dia dah intercept line of sight di sini, line of sight here, dan intercept di sini. So maksudnya ni adalah obstruction. So, kita kena consider dia sebagai obstruction attenuation. So in general, kalau ikutkan barriers contribute to decrease noise level when the structure breaks the line of sight between source and receiver. So dia tak ada direct transmission of noise. Okay. Sound wave diffracts around the obstacle to reach the receiver. Dia tak ada straight punya line lah, straight transmission. Dia sama ada refract dulu atau reflect, dan baru dia sampai dekat receiver. Okay, that's the interpretation for this obstruction attenuation. Okay. The next one, kita ada juga tadi kita tengok lebih kepada barrier, lebih kepada structural. Yang ni factor yang keempat. Okay, the next one, third factors. So the fourth factors relate to the vegetation. Vegetation and under attenuation lah sebab relates dengan available trees. Trees, because trees itself can help to attenuate sound and calm the noise. Maksudnya dia akan break the transmission of noise dan dia akan refract to many direction. So that at the end, contohnya ni kita punya source kat construction site, okay, and then ni kita ada nearby resident. So kalau in between ni kita ada banyak pokok kan, pokok. So we don't have a strict transmission or direct transmission here. Because all of these trees block the transmission path. So the sound can reflect, kalau pilih ni kat surface it may reflect. So at the end it helps to calm the noise or reduce the noise. So maybe kalau kat sini from source dia 80 di decibel related dBA. So maybe due to this pokok-pokok kan dia boleh jadi 75. So maksudnya ada reduction lah. That's the simple example to represent the situation of condition. And then relevant attenuation due to vegetation are only for depths of foliage of greater than 10 meter. So maksudnya dia ada different category of efficient trees and shrub, okay, which are thick, waxy leaf, dense evergreen foliage and branches that extend to the ground. Maksudnya pokok yang lagi besar pokok dia lagi efficient lah sepatutnya, yang banyak daun tu semua. So that one will attenuate the sound itself or noise itself. Okay. So at the end, it will influence the noise propagation. Okay, kalau kita tengok table kat sini, dia ada some summary on the depth of foliage of the trees. with different region of frequency. Yeah. Boleh cuba lucu lah. Yeah. Of this factor. And the last one, I think this is the fifth factor, which may influence or affect the noise propagation is mode of operation. So mode of operation ni refers directly to the construction plant and machineries. So it is actually another factor, main factor of noise fluctuation at construction site. Okay. Because in actual or in reality, a machine or any construction plant and machineries does not always work at full power. Okay. If, let's say kita ambil bagi contoh lain, macam tadi excavator, lorry and related trucks for the earthwork. Maksudnya throughout the construction process, not all the machineries on site working have the same working hours, because sometimes they take turns, okay, depending on the sub activities, and some of the machine will be totally switched off or without turning off the engine while waiting for the loading, while waiting for the unloading. It will idling here. So in terms of mode of operation, we can categorize into three main categories. Okay, the first condition, full power. Maksudnya memang dia kerja terus, dia punya machineries work at the full power. And then we have idle, with the engine on but not working, so idling. And then inactive, when the plant and machineries engine have been turned on, right? Ini dia punya list of excavator, list of equipment. Okay. Three condition or operating mode, either full, idle or off. Okay. So that's for the factors influencing propagation. So harap semua nilai boleh bilik. Okay, this is actually the final subtopics for the construction noise propagation. We are going to get in brief for the sound indices. Okay, again, LP refers to the sound pressure level, SPL. Because I mentioned awal, we need to differentiate SPL or LP with another one, LW. And we need to bear in mind LW or sound power level is directly refers to the individual machineries. Okay, so power level itself refers to the power level of the machineries. And then we have LAEQ. So actually kalau kita tengok maksudnya ni LP, memang straightforward, sound pressure level, and then we have LAEQ. So basically LAEQ dia pun merupakan sound pressure level, tapi kenapa dia jadi macam ni, sebab dia dah ada dia punya weighted ataupun dia punya condition lah. Okay, so A here refers to the weighting, A weighted. And then EQ refers to the equivalent continuous. This is the condition for this sound pressure level. So at the end kita call it as LAEQ. So the full name will be A weighted equivalent continuous sound pressure level. Itulah dia punya apa? Sebab LAEQ ni part of the main parameter that we need to know, sebab later on especially relates to the calculation, we are focusing or we are using this LAEQ. So we need to know the difference between LP and also LAEQ. So LP is basically for the individual calculation split. Individual values. LAEQ is the cumulative or the average. Okay. So nanti saya akan tunjuk juga figure for this LAEQ. And in this bracket, it is actually the same, what we call the same symbol yang refers to this LAEQ. Sometimes kita boleh tengok LAEQ ni dia tulis LEQ je. LEQ, LAT, T ni pun just equal to this EQ. But equivalent of this capital P refers to the time for this equivalent continuous record. Okay. And ada juga dia tak mention as LAT, we call it as LT. Okay. So in overall dia benda yang sama, so kita kena inilah identify. Okay, kita kena recognize. Alright, and then the other noise indices atau pesawat indices yang quite relate adalah L10 and L90. Jadi kalau kita ingat balik, previously in our part 1, okay, I have mentioned these indices for the schedule by Department of Environment. Okay, kita tengok kat situ ada L10 and also L90. So basically L10 is the sound level, L memang refers to the sound level, exceeding 10% of the specific time. So maksudnya kalau 1 jam, so 10% of the sound level represented by this L10. Okay, which is similarly to the L90. L90 they make 90% of the specified time. Okay, so in other words, L90 ni dia boleh represent ambient or background noise. So nanti in calculation pun saya akan highlight again regarding this indices L90. Okay. And then for the LDFMX adalah another example for some indices. Yang ni sama juga, some pressure level dengan A weighted, F ni put another response fast. Usually for construction noise, for indicative noise such as construction, traffic noise, kita akan menggunakan weightation fast. Okay, for your information, kita ada fast and slow. Okay. So here F refers to fast response. So maksudnya dia record active punya condition lah. And sama juga max refers to the maximum. Okay. That's the sound indices related for our scope B, and then this is how we want to relate with the previous indices. Kalau kita tengok kat sini, Lmax. Okay, here we have Lmax at this point 85. Just example, just the same here 85, and then we have another Lmax 77. Okay. 77 dBA and 85 here. So kita nak tahu LAQ within 60 seconds. So we need to calculate this too. So LAQ will be its average. That's why it is equivalent continuous sound pressure level. So the LAQ for this situation is 75. Right? Sama juga kat sini kalau kita tengok from T1 to T2, dia punya measurement duration ataupun period. This is these grey boxes represent the LAQ. Maksudnya from this fluctuating values, the average is represented by LAQ. It within this specific measurement time. Okay, another thing again relates to L10 tadi, I mentioned L50. L50 senang sikit sebab dia half of the measurement time, and then L90. Okay. So this is the interpretation for some indices. Right? So nanti kita cuba relate dengan calculation lah. We are going to cover the calculation part. Alright, so saya rasa that's all for second session. So far okay semua?
Okay, doktor.
Okay. Harap-harap
Selalu kalau final calculation keluar ke?
ada.
Ada eh?
Ada. So kebiasaannya final exam ada mix lah teori dan juga calculation. So kalau kita tengok, so far kan kita ada 3 part lah, part by BM Dr. Rosana and then Dr. Meruzat and saya punya part. So most of the theory basically selalunya akan come from the first two part, Dr. Rozana and Dr. Rizal. And saya punya insyaAllah hopefully ada mix lah some theories and calculation. So saya harap semua boleh faham in terms of calculation sebab saya rasa calculation senang sikit kot untuk target ataupun obtain marks. Okay? Boleh ke? Kita sama-sama lah explore the calculation part.
Doktor, ada example calculation tak? Macam past year question.
Alright, so example saya cuba kita cuba cover esok lah. Esok kita akan cover on calculation part. And then untuk calculation past year, sebenarnya dia as long as kita faham apa yang saya dah bagi example kat kelas, so hopefully boleh jawab lah untuk calculation for the actual exam. Okay? Tengoklah contoh-contoh example. Right? Boleh kan semua? Masih okey tu? Ni pun dah putus.
Boleh doktor.
Boleh Alright, so kalau tak ada apa-apa soalan lagi, saya rasa setakat ni dulu untuk second part. So, hopefully to see all of you again by tomorrow. So before that, scan this QR code for your second record untuk today's class.